Hey everyone. So, as mentioned at the end of the last video, I want to draw your attention to one of the really great sort of documentation and replication features that Google Refine has. So we've seen how it can use merging, mass editing, merging and clustering as a way to help clean up your data and get sort of more uniform data values. We didn't go the whole 9 yards with this, but you see how that worked. Also, how we can do different kinds of sort of slicing and dicing, faceting, sub-selecting. We can export right out of the data view that we have directly to like a CSV file or an Excel file if we want, and it gives us a really handy way to get little subset views of our data if we want to do additional kind of work on it. Or share it, with a colleague or something like that. So the next thing that I want to look at is, or that I want to demonstrate, is actually a feature called undo redo. And most spreadsheet programs, most software programs have an undo redo function that we can use in the through the edit menu. And it's, I mean, what's interesting, of course, is that, again, because we're using OpenRefine in a browser window, the undo redo is actually like for our browser, for Firefox or something like that, which is not going to get the effect, which is not going to produce the desired effect. But OpenRefine has built in something much more powerful. So if you recall, we've made a bunch of changes to our data, and what's great about this program is that it actually creates this undo redo tab that shows us all of the activity that we have performed on our data set up to this point. So not only does this mean that we can kind of come back and redo indefinitely, right? We could have done 100 things in here, and we can just step back, either one by one or piece by piece. So for example, you see here, that's back where I created the chain name by duplicating that column. That's, I guess, where I did the mass edit of A and P. A lot of this is out of view right now, right? But I'm kind of going down here doing all of these edits in chain name. And I can sort of step back and step forward as I prefer in this. Now, that of itself is really valuable, right? Because it means we don't have to be worried about making mistakes. We can go ahead and mess around and play around and know that if we make a meaningful transformation of the data, right, which is not going to include like sorting, because that doesn't actually change the data, it just changes our view of it. But anything we do that actually transforms the data is going to be captured. What we usually, the sort of common term for this is a macro. A macro is basically a tiny program that runs within an existing software program. And again, spreadsheet programs like Excel do have macros. It's just that they are generally not created automatically. You kind of have to sort of turn them on and know how to use them. And OpenRefine is just doing this for us in the background. That's great, but even better than that is the fact that OpenRefine allows us to actually extract and apply this macro to another data set. So if I click extract here, what you'll see is it has highlighted all of the edits that I made up to this point. And if you look carefully, you might notice that this data format in the right-hand side is quite familiar. Yes, folks, that's JSON. So actually, the macro that OpenRefine generates, it generates in JSON. This is a regular plain text JSON like you guys did for your assignments a couple weeks ago. And even though this is we don't really need to know intimately what the structure of this is or exactly why it's structured this way, but I will point out that this has a much more direct description of what's happening, of what has happened in our edits. So if we see, it says up, core column addition, description, create column chain name, and index 3 on column trade name using expression grel value. We're going to touch on that grel thing in just a second. This engine config, probably not relevant to us. New column name, chain name, insert at index 3, right? So that's actually the fourth column because we start counting at 0 usually. I believe that's the case. And, and then we come down here. We say, oh, mass edit cells in column chain name. Now, in another case, if you had made that transformation in a spreadsheet, it would just be done, right? There wouldn't be anything, there wouldn't be any sort of evidence trail, if you will. But here you can see it's actually showing us, I'm editing, it's not blank, it's not from an error, it's from actually this value to this value, right? So this doesn't get you off the hook of having to write down in your documentation the edits that you're making, but you can make them a little bit more broadly because all of them are actually captured here in this JSON. Now, again, another huge feature of this is that not only do I have this nice detailed record being automatically produced for me, but if I, for example, let's say this was periodic data, or even not, let's say that I just had a different version of this data that was coming out and I wanted to, and I wanted, you know, if I got a new set of this data, because let's say they had to re-export it for some reason, and I get a new copy, I'm going to have to do all of this work over again, right? I'm going to have to go back in and create my new column and edit those cells and do all the stuff that I did, which, you know, isn't terrible again because it's still much more efficient than it would have been, say, in a spreadsheet program. But the real power here is that I can actually take this JSON. I see I just did select copy. Okay, now it's on my clipboard, right? Just regular Apple V, Apple C going on there. And now if I were to come back, let's say, to, or not come back, but let's say I were given access to another copy of the data. Okay, so once again, we see it's still having, you know, this is, again, this is the same data file, but, you know, just imagine, as I said, imagine it is periodic data. It gets updated every year, let's say, and it's the next year's time. You know, rather than having to go do all that work again by hand, I can actually flip over to my undo redo column. You see I have both extract and apply here. So I'm going to choose apply. And it says paste and extract a JSON history of operations to perform, right? So that JSON file, right now I'm copying and pasting it between the clipboard, but I could just as easily paste it into a text file, save it as a JSON file or a .txt file, and leave it as, you know, cleanup operations or something. And here I go, I paste it in here, perform operations, boom, right? All of the work that I did in the last case has now been reproduced here instantly. This is something that I, for example, used at the journal with a colleague who had to update data. He was working on a data series that first had to be updated every month, and then it had to be updated every week, and then they started back updating it, and it just became a nightmare, right? And I ended up creating what was, I believe it was a 93-step macro, you know, very carefully to replicate a sort of analysis process that he had designed, but what it meant was that instead of taking him 20 or 30 minutes every week or more, it literally happened instantly. So it's hard to overstate the value of this feature of OpenRefine. It's really just going to make your work much more efficient and effective. Now, the other thing that I want to introduce you guys to with, you know, through this data set is actually yes, is actually something that, and I'm going to look at my other data file here because there's something else looking. So I'm going to go back to my other version. So I'm going to just leave this for a moment, but it doesn't actually really matter. I just want to, the other one demos it a little bit more directly. I want to introduce you guys to a concept. Oh yeah, because this is sorted alphabetically. That was what it was. I want to introduce you to another concept which is extremely powerful. It exists in OpenRefine. It exists actually in most programming languages. We will see how to translate it into a programming language in a couple weeks, but I just want to put this in your mind, which is that which is something called, there's something called regular expressions. Now, what regular expressions are good for, so far the kinds of analysis, the kinds of sort of filtering and sub-selecting we've been trying to do, in some ways has been relatively straightforward, right? We've been dealing with, say, the entire contents of a cell, right? I have A and P number 762, I want to make that just A and P, no big deal. I have my mass editing, I have my clustering, I can use that to just kind of cut off the ends and make all of that the same. What is challenging is when we have, you know, cells that share a particular feature, but that may be the only feature that they share and there's other data mixed up in it. So to take an example of this, we're actually going to look at the street address here. If you look at the dictionary, you'll see that, that was posted on Piazza, you'll see that actually this triple pound sign at the end of the street address is meaningful. It actually means that the company receives mail at an address different from the one listed or different from the location where it operates. Now, obviously, in this particular case, I'm not really sure why we would, you know, maybe we want to look up actually their sort of headquarters of operations. Maybe that's going to give us some more information about who's really running this business. And so in order to do that, we would need to be able to pull apart those street addresses where mail goes elsewhere and those where it actually goes to the establishment's direct location. So how would we do this? This would actually be very difficult to do. I mean, we could obviously just look at them, right? We could just scroll down and for every address, you know, we could facet on the address here, right? See how many distinct ones we get. And it might not be too bad, you know, we could maybe go in here. But again, this is one of those cases where, gee, there's an awful lot of, you know, there's an awful lot of things in here that have, you know, some pound signs or lots of pound signs. It would be tedious to go through this, and also we would want to be very careful that we actually knew that we were getting it right. This is where regular expressions come in, and so we're gonna start this here. We'll come back probably the second half in the final video. But want to sort of highlight this concept that what we want to be able to do is we want to be able to programmatically separate those rows that have a street address that has pound signs at the end, because that tells us that they received mail at a different address, from those addresses that do not have pound signs at the end, but those pound signs are going to be the only thing that they actually have in common. So to start doing that, we are going to look at add column based on this column. And we come up with this window again, and I'm just going to say, I'm going to give it a name as different mailing. Okay, so what we're going to use here is something from, so GREL stands for Google Refine Expression Language, GREL, right, indicated there. And if we want a dictionary reference for this, this is actually in our help section is where it's going to give us sort of plain language descriptions of the various functions that are available, and sort of how to use them. Now, we're not going to start by reading that. Fortunately, I have a little bit of background in this, so I have some idea, and I've done this before, that I am going to use something called value match, which is basically going to say, find things that match the expression or string that I put into this, in between these parentheses. So as a very simple example, if I just put in this first address, oops. Nope, not close. I probably have some kind of, Riverdale. Does not appear to be exactly the same as the address that's there. That is a little tricky. Well, and actually that sort of illustrates it, right? Like there might be some white space around this. It's hard for me to tell what exactly that is. And some of you ran into this with your JSON as well, right? Where you had invisible characters or things that looked right, but for some reason the computer was misinterpreting. That's exactly why we have things like regular expressions. So what I want to do, the sort of simplest way for me to do this, because if we noticed from our quick overview before, some of the addresses had 2 pound signs, some had 3, some had 5, some had 7, right? So I don't want to get too tied up with how many pound signs there are at the end of how many pound signs there are in this address. All I want to do is I just want to say, look, I'm actually going to go sort of backwards to this and say, look, if it doesn't have a pound sign, and the way that I say doesn't is I put in a caret. So these 2 forward slashes say what comes between these things is a regular expression. It is a pattern matching expression. It is not to be interpreted literally. And so what I say there is I have this little caret, and the caret means anything other than the thing I put in here, which is a pound sign. Actually, I think I did that wrong. I think it's like this. Oh, no, wait. Yeah. So anything that is not a pound sign. And then I have this other thing where I say if it has, now the dot, the period, stands for any character. So if it has any character any number of times, nope, sorry. Oh, I'm getting confused. If it has not any character any number of times, then I want you to flag it. Okay, that was really confusing. I'm going to pause here. We'll come back to this exact expression in a second, and I'll walk you through it one more time. We'll talk about how it actually does this matching, and also look at a couple of other examples. Don't fret. Regular expressions are tough, but they are extremely powerful. They're actually kind of fun. I like them, and they do a lot of really important things. So see you back here in a minute.